Hey guys, so in this video we are going to see how we can use events to communicate between different graphs. So let's start. First of all, the event system that we have in Unity Visual Scripting is quite similar to the one that we have in Scratch. So basically how the events work in Scratch is that we can use the block broadcast to broadcast an event to the game, and all the objects that implement the when I receive block. So for example, the label ready is broadcasting the event start game, and the game manager is implementing the when I receive start game. And so when the sprite implements the block when I receive, it basically just runs whatever code is connected to that block. So basically, we are communicating between the label ready and the game manager by using this event system. Now, to be in Unity is really similar. Actually, I can show you once again the comparison between the blocks that we are using and the blocks that we have and the nodes that we have in Unity. So we can see that we have a broadcast block and a custom event trigger, and we have a when I receive event block and a custom event node. So this has like a comparison one-to-one, and we also are going to use this one when this sprite click, which we also have a node exactly for this. But going back to the events, to be honest, I don't like the event system that we have in Scratch, and I don't like the one that we have in Unity. And but the Unity one is slightly better than the Scratch, and let me just explain you why. So in Scratch, we have like this broadcast block, and this broadcast block for me and for someone who is coding, and if you are learning how to code, these I think that this is my opinion, but I think these might get you to think in a way that it's not the best way when you are coding, because and going back to the what we talked in the last video when I talked about variables and how you should always make your variables private by default and only increase the level of access as you need to, because if everyone has access to everything, then it gets really hard to follow the flow of execution and gets really hard to understand who is changing that variable from where. In the same way, the event system also allows to make kind of a mess when you are using a lot of events, because it gets really hard to follow the flow of execution. Because, for example, in this game, we have the label ready that when the player presses the sprite, it basically broadcasts a start game. And in Scratch, a broadcast means that, okay, this event is sent everywhere. So all the sprites can just listen to this event using the block when I receive a certain event and can do stuff about it. So it gets really hard to understand. Just looking at the web already gets really hard to understand. Okay, when I click the sprite, who is listening to this event? I do not know from here, from this sprite, So I just know that okay, I'm broadcasting this to everyone. So all the sprites that I have here might be listening to the event. And of course, when we are implementing the game, it gets really easy because we still know, okay, now I look at the game and I say, okay, who is listening to the start game? Probably the game manager, of course, probably the targets, because when the game starts, the targets start creating clones, probably the crosshair, because when we start the game, we show the crosshair. And I don't know if we have anyone else listening to this. Actually, we don't have it. But you see, like, I don't remember, right at this moment, I don't remember who is listening to this event. And so, in 6 months from now, when I come back to this game and I say, okay, I broadcast a start game, okay, who is listening? I need to go sprite by sprite and say, okay, is this guy listening to this event? Is this guy doing something when I press the sprite? And I have no way to know it. And this gets really hard when you're trying to debug something, because you might be having an error and you need to follow the flow of execution of your code. And when you have stuff like this, like, okay, broadcast and everyone can be listening and a lot of sprites, in this case, we have like 1, 2, 3, 4, 5, 5 or 6 sprites that are responding to this event, and it gets really hard to follow. Okay, so this is why I don't like this event system. I understand why it exists, and I understand that it's really easy to work with because I don't need to worry about references. I don't need to worry about um, architecturing, like making my program architecture or thinking about that. But if you are learning how to code using this system, then when you actually start implementing actual code, you might still bring this way of thinking, and that gets into a mess really soon. Now, Unity is a little bit better than this because the event system that we have here also works as in Scratch, so we can trigger events like the broadcast. We can trigger a custom event, and someone might be listening to that custom event. Now, the only difference that we have here, that we have in Unity from Scratch, is that while Scratch, the broadcast block sends this message everywhere, so anyone in the entire game, all the sprites might be listening to the event. In Unity, this custom event trigger node, you need to specify who is the receiver of this trigger. So you need to specify who exactly is going to be implementing this node, which is a lot better because in this way, when I look at this custom event trigger, I say, okay, so is this guy that is receiving this event? And then I can go to that graph and say, okay, what is this guy doing when it receives the event? And this is a lot better and a lot more closely related to what we have in actual code. So Unity has the implementation in Unity is, I think, it's way better than we have in Scratch, but the system is quite similar. The only difference is that here you need to specify who is listening, and here you don't specify it. Now, I wanted to talk about something. So we have the broadcast, start game. Oh, okay, I remember. So another difference that we are going to implement in Unity is that, like we just saw, when we press the label ready, we are broadcasting this everywhere. So the label ready is communicating with the crosshair, is communicating with the game manager, is communicating with the targets, all this. This is also not a good practice, once again. So when we are thinking about the architecture of our application, when I say architecture, is the graphs that we have, the game objects that we have, who is talking with who. When I say who, I'm talking about the graphs. I see them as entities. So my label is an entity, my crosshair is an entity, my target spawners are entities. All these guys are different entities and they talk to each other. This is the way I see it. And my main rule of thumb is that we need to keep the connections as fewer as possible. So we want to have a small number of connections because once again it becomes easier to follow the flow of execution and it becomes easier to debug because if this object is communicating with all of them, then it's really hard to understand when you have a problem, okay, where is the problem? What is the other object that is having a problem? And if I change something in this object or on any of the other ones, it might break the connection. So main rule of thumb, try to keep the connections as fewer as possible. So for example, here, the label ready is communicating with a crosshair, which for me doesn't make sense. I mean, the label ready doesn't need to know that a crosshair exists. The label just need to know, okay, what do I need to do? I need to send an event when someone clicks on me. When someone clicks on me, I send an event and I hide myself. That's it. I don't need to know about the crosshair. Of course, in Scratch, it actually doesn't know about the crosshair because it doesn't have a reference because we have this broadcast, a general broadcast event. But either way, they are communicating with each other. So, and that's why usually we have like a game manager or something like an entity like that becomes the main point of contact between all these entities. So the label ready is not communicating with the crosshair. The label ready will, in Unity at least, the way we are going to implement it, the label ready is going to tell the game manager, okay, start the game. And then it's the game manager that knows that it has a crosshair and that knows that it has the target spawners and it knows that it should start the time. Is the game manager that has references to all the other objects. So this is the main point of contact that we have. And so the label ready does not know about the crosshair. The crosshair does not know about the label ready. And this is the best way when you are thinking about your games and applications to keep the number of connections small. So in a way that objects do not know about each other unless they actually need to. Okay, so now that we have like all this theory, let's see how we can actually implement this. And we're gonna start by implementing the label in our game because we haven't done it or yet. Okay, so first let's import our label, and let me see from scratch. Sorry, I'm trying to find where I have the assets. Okay, here, and label ready. Okay, so we import the sprite into our project, then we can just drag it into our hierarchy or into our scene. Now we have the label in our scene and it's centered exactly like we want, but it's behind all the other sprites. So remember that you need to adjust the order in layer. And let me just check because I don't remember which layer we should put the label ready. So the label ready should be on 7. I think it's layer number 7. Yes, this is it. Okay, so now we have our label ready, and the idea is that when we start the game, the player should press the label to actually start the game, so that the game starts running. Okay, so we need to create a new script. Let's create a new script from here, because it's also another way. In the last video, I created it from here and then assigned it. You can also just add a script machine to the game object where you want to create the script. When I say script, it's a graph. Sometimes I mistake because script is in proper coding. And okay, so we have a graph. We create a new one. And scripts. We're going to call it a label. And it is assigned. And now we can add it. I think the main difference between creating the graph on the project tab and then assigning to the game object or using the script machine to create the actual graph is that when you use the script machine, it creates automatically the on start and on update event, which in a way is always better because it's usually we use one or both of these events in most graphs. So it's easier this way. Okay, and now what we want is that when the player presses the label, let me just check here. So when the player presses the label, we broadcast the start game and hide the label. Okay, so let's see how we can implement this when this sprite click. We already saw here that we have a node for that. So the node that we want to use is this one, on mouse down event. So let's go back here and on mouse down. And we have this event. I was saying that we most times we use this event. I think in this case we are not going to use them, but or whatever. So on mouse down, which is the same as when the sprite is clicked, we do two things. We hide the label and we broadcast the message start game. Okay, so hide the label. We already know how to do that because we already know how to disable sprites. So we need to go to the sprite renderer, set enabled, and we set the label enabled false, and then we are going to broadcast the message. To broadcast the message, we have this node which is custom event trigger and has arguments. We'll talk about that in just a moment. So let's just add a trigger. Let me see if it finds like this. Event trigger? No, it's not an event trigger. No, trigger custom event. This is the one we want. Okay, trigger custom event. So we press the label, we hide the label, and then we just trigger a custom event, and let's call it start game. Okay, so now let's test to see no one is receiving this, but at least just see if we are catching the on mouse down and if the label is actually disappearing when we press it. Okay, I'm pressing the label, it's not working. And it's not working because to receive the on mouse down event, our label needs a collider. A collider is a way that we detect, is a component, not a way. It's a component that Unity uses when we want to detect collisions. And to detect a collision with the mouse down event, the label actually needs to have a collider. So let's add a collider, a box collider 2D. We have different types of colliders. I'm not going to get into the different types of colliders, but basically we are working in 2D. This is a sprite, so we need to use a 2D collider, and in this case it's a box collider. And it's a box because the collider will have exactly the same shape as the label. And so now that we have a box collider, we can start again. Let's check. And now I press the label and it disappears. So it's working. And another thing that we need to do is that since it's a collider that is responsible for detecting the input, and we are basically just disabling the sprite render, what this means is that the label is still present in our scene, and if I click again in this space, it will still detect the event because the collider is still there. So besides disabling the sprite, we also need to disable the box collider. So I'm going to break this connection here, and we should probably have a node for that. So box collider 2D and enabled. Oh, it doesn't work like that. Okay, so box collider 2D set enabled. Yes, this is the one that we want. So we hide the sprite, we disable the collider, and then we call the event. This is a proper way to do it. And okay, so now we have this. Let me just reset this one. Okay, so now we have the code for the sprite. So basically what we did is this one here. In Scratch we don't have an actual collider, so when we hide a sprite, the input just stops working on that sprite, so the sprite disappears from screen. It does not detect any other input after that. In Unity we need to actually work with colliders for the input. And now we are going to receive the event, just like we did here. We are going to receive the event on the game manager. So we go back to the game manager. Let's just open the script, and we are going to add a node here, which is a custom event. So actually, when you search for custom event, you can see that the both nodes that you need when you are working with events. So someone is triggering a custom event and someone is listening to a custom event. And this one is listening to the start game event. Once again, this is something that I don't like, at least, because I'm typing start game, and I'm typing start game again here on this one. If I make a typo, the game might not be running just because of a typo, and it sometimes gets really hard to understand what's happening. But there is no other way to do it. I don't have a drop down here like we had in the variables. Okay, so when the game manager receives the start game, it's going to do things. Okay, so what is the game manager going to do? The label is already disappearing, so the label already is already dealing with hiding itself. Now what the game manager needs to do is to enable the crosshair, because the last time we worked with the crosshair, we removed disabling the crosshair at start. So you can see that the crosshair is actually here and visible on screen even before we press the label ready. So let's just fix this first, and let's go to the crosshair. Okay, so the crosshair, we had this. So when the game starts, we center the crosshair and we disable it, and then but while the game is running, the crosshair is moving and following the mouse cursor. Now we can create, if we had something like we had in Scratch, we could just listen here to the start game event and the crosshair would receive the event. But in Unity, it doesn't actually work that way, because we need to specify who is receiving the event, which actually we didn't do when we were implementing the label ready. So I forgot about doing that. So on the custom event, on the trigger custom event, you have the receiver of the event here. And you can see that right now, even if we try the game, and even if my game manager is actually listening to the start game event, it wouldn't receive it, because the label ready graph is sending or is triggering the custom event on this object only. So we need to add a reference here to the game manager, so that we can say, okay, trigger the custom event start game on this object on the game manager. And for that, we need to create a variable, and it cannot be a graph variable because we need to assign the game manager from the scene. And to assign it from the scene, we need to create an object. So remember, if it cannot be private, it cannot be a graph, so the most private, then it's the next one. So we need to create an object, and let's call it Game Manager. And the type of object that we want, if I'm not mistaken, it should be a game object. And I think I can, yes, and we can define it already here. So it's a game object, and the value is game object. So if you open here, you see that it's showing me all the game objects we have on the scene. So basically it's showing me this list that we have here. And now that we have here, we can input the value of that variable here as the receiver of the custom event. So in this case, get object variable, and it's the game manager. So basically, we press the mouse on the label, it hides itself, and triggers the custom event start game on the game manager. And if you come here to the label ready and you select the label ready, you can see that probably I have the variables here as well. So we could just create the variable, we couldn't assign the initial value, and just drag the game manager from here into the slot here in the variables component. So now going back to what we were doing, now the label ready is triggering the event in the game manager. And now we go to the crosshair, which was the one that we were editing before. So when it starts, it hides itself and everything. But now what we need is that the game manager is going to need to enable the crosshair when it receives the start game from the label ready. So we are going to create a new custom event here. And we'll take this chance to also see what this argument is all about. So we are going to create a custom event here called enable. And actually, we can even take this from here and connect here. So when I say to enable the crosshair, I don't need this set position, because it is also like it's always updating the position to the cursor. So we don't need this. So basically, when I call the custom event enable on the crosshair, it will, in this case, enable the sprite render. This is what the game manager wants to do. But for example, on start, we want to disable the sprite render. And another way to do it, just to show you, would be to create a new event called disable, and this would disable the crosshair. But now, we are basically duplicating, we are creating another event, duplicating the event to have like the opposite effect. And this is where we can use arguments. And arguments are basically values that we can pass to the event. So instead, for example, if we want to enable, we can pass a true value so that it's enabled. If we want to disable, we could pass a false value to apply here. So let's see how we can do this. We can add here a new argument. And you can see that the argument is here. And it's a generic one. So when we create an argument, we are not saying, okay, this is a number or a string or a boolean. So it's a generic one. But we can connect this generic one to the boolean. So now, basically, what I'm saying here is that when I call the custom event, I can pass an argument, in this case a true or false, that will be applied to the sprite render to enable or disable the sprite render. So, for example, on start, I can trigger a custom event on this object. This is correct. That is called enable. So basically on start, I'm calling this event with enable, and I'm sending an argument, and this argument is going to be a boolean withdraw, which is a boolean value basically. And when the game starts, I'm passing a false value as an argument, and this false value is coming here, and we are using that false value to set the state of the sprite render set enabled. So basically this is calling events with an argument. So the thing that arguments are values that we can pass when we are calling an event. So instead of only calling an event, we didn't have this option in Scratch. In Scratch you say, okay, broadcast a message, and that's it. Here you can say, okay, broadcast a message with this value, associated with it. So called enable with the false value, or called enable with a true value. And then we can use that value through the flow that is connected to the node that receives the event. So In this case, we are hiding the crosshair when it starts. And now we go to the game manager and we need to access the crosshair. And to access the crosshair, we need a variable. Let's call it crosshair. We already know that it's a game object and we can assign it from here. And now when the game manager receives the start game event, it's going to trigger a custom event on the crosshair. So get object variable crosshair. So it's going to trigger the crosshair, the enable event on the crosshair, and it's going to pass a value of true to enable the crosshair. So you can see that we can use events also so that we don't repeat code. So instead of having the sprite sender here connected on start with the false, then when it receives the enable with a true, we can use just one event with an argument and we can reuse it and call it with false or from the game manager with a value of true. So when the game manager receives the event, it enables the crosshair. Actually, let's just check if it's working. I don't know, this really bothers me. I don't know why we are always like getting a lot of errors here. This is something from visual scripting, but it really annoys me. So we have the game, so you see that we no longer have the crosshair visible on screen. It's actually still following the mouse, the mouse cursor, but it's not on screen because it's disabled, the sprite render. And when I press the label disappears, and now you can see the crosshair. And we still have the cursor visible, so let's just deal with that as well. So besides showing the crosshair, I think we should have something about the cursor set visible. And we are going to just hide the cursor. So let's try again. So label ready, I have my cursor, I press, and now I have the crosshair. And now if I click, it should be shooting. Yeah, you can see the ammo here is decreasing. Okay, but now we need to make another change here in the game manager, because when we have the label ready or before showing the crosshair, the game is not actually running. So the game is running in a way, but all the variables and all these that we are doing here, so the time should not be counting here because the player is not yet playing. And even if I press, I shouldn't be losing ammo because I'm pressing here on the screen. Only after we press the label and I have a crosshair, we should enable all that behavior. And to do that, we are going to need to create a new variable here in our game manager to know if the game has started or not. So in a way that we only run all this code for the ammo and all this code for the time when the game has actually started. So let's create a new variable, in this case a graph variable, because it's a variable that's only going to be used in the game manager. And we are going to call it game started. And this variable is a Boolean one, so it's either true or false. And when I receive the start game event, we are going to set the variable to true. And let's set here, so set variable, graph variable. We're going to game started, and it's a Boolean. And we set the variable to true. And now we are going to use this variable to prevent from this code to run while the variable is not true. So I'm going to break this connection here, and we are only going to continue to this code if the game started variable is true. And we know that we have the if, and we are going to get the variable, get graph variable, and game started. So if game started, we continue with the rest of the code that we had before. Actually, let me see if we have other ifs. If else? No. Else if? Okay, we don't have it. I was just checking if we had something like this. Oh, we don't have in Scratch as well. Okay, so never mind. And now we are going to do exactly the same here on the update to when we are where we are updating the time. So basically the same thing. A node if, and here we do a get variable, a graph variable, and a game started. And we only start all that when the game is actually started. So now let's test, and basically now what we should see here is that when I press this, before pressing the label ready, when I click anywhere on the screen, the AMO should not decrease and the time should not change while I haven't pressed the label ready. So the game started, let's see. Okay, so now you can see that time is not decreasing, I'm clicking the screen and the AMO is not changing, because you can see that both updates are being stuck here, because my game started variable is false. But as soon as I press the label ready, the variable comes true, and you can see that now everything is running. So the time is running, and if I press, I'm shooting. So yeah, so this is it about the events. Our game is starting to look like what we had in Scratch, and we are going to continue with the implementation on the next video. So thank you guys.